So a matrix is going to be filled with a bunch of values. Each of those values can be treated as an individual variable. Also, subgroupings of those can be treated as individual variables. So we can take a matrix like M. Let's say it has 3 rows. We can treat each of these as their own variable. So I can look at just this group, maybe this column. Keep in mind it needs to be square versions. And the way that we access and modify and change and do all the fun things with each subgrouping is through something called indexing. So indexing is the act of accessing individual elements of an array or subarrays. For MATLAB, our indexing starts at location 1. In a lot of other programming languages, it starts at 0. So keep this in mind if you're used to something else, if you have previous programming experience. If you don't, then that's great. But indexing locations start at 1. So the first location here would be 1. And they increment as integers. So you have locations 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. You can't have location 1.5. That's just not possible. And then it ends with however number of elements in that dimension. So this is row 1, 2, 3. This is column 1, 2, 3. Or it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Vectors can be indexed or accessed with a single number referring to location. So remember, vectors are a single row or a single column. Let's say we have 0, 1, 3, 7 and 0, 1, 3, 7. We can use a single number to access the locations. So this is location 1, 2, 3, 4. I can say, let's say it's A4. Our notation for that is we type the name. So here's the name of our variable. And then we have open close parentheses. So even though it looks like a function, essentially you can think about it as a function where the parentheses act as like you're inputting the location and it's sending back what is stored there. And you just type in the number location you want to access. You can also access multiple locations at once. So you could say 0 is not a location. You could say location 1, 3, 7. And that will give you locations 1, 3, and 7. So it's a subarray, it's a subgrouping of elements in your array. Same thing for a column. Matrices can be indexed in 2 ways. One, it can be indexed with a single number. I'll jump down here. It's called linear indexing. A single number where if we have our M matrix again, it's going to start with 1 here. And it's gonna go down a column. So it's location 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's as if it was stacked in a single column. It stacks the columns and then just grabs the number according to that column. And that's a single number. And same idea, you can access an array. So you can access 1, 2, 3, 8, and 9. Or we can do row column indexing, which is more common, where we have 2 numbers. We identify which rows and which columns we want to access. So if I want to access element in row 1, column 3, it would be row 1, column 3. It would be this number here. If I wanted to access the elements in row 1 and 2, and then column 3, it would be rows 1 and 2, column 3, so it would be these 2 numbers. That's subarray. And these arrays in here can be created using any method. A lot of times you'll see the colon operator when I want to access locations 1 through 7. We can also use the end keyword for automatically identifying the last element in the row, column, or vector. So if I say my vector end, it's going to automatically grab the last element. If I say end, it's going to grab the last row, last column. That's really nice when we don't know exactly how big our arrays and vectors are going to be. Like I mentioned, the column operator is commonly used for indexing locations in order to create arrays. It can also be used to indicate all elements in a given row or column. So here's some special indexing syntaxes. So if I do a open close parentheses colon, that means access all of the elements. Specifically, it's going to refer to all of the elements in a single column. It's going to stack them in one single column vector. If I do array colon and then columns, this is essentially saying grab all the elements in the row for these given columns. Or if I do array of rows and then colon, this is all elements in the column. So these are some special syntaxes we can use in order to shorthand note that we want all of the rows or all of the columns or all of the elements stacked on top of each other.